When method touchMoved gets called, it receives a motion event object that could contain information for multiple pointers, multiple fingers at the same time that we're moving on the device. So for that reason, we use a for loop to iterate through all of the pointers for which there's information in the current motion event object that's being passed into our touchMoved method. Now, based on the current ID, the current pointer ID, meaning whichever finger is currently represented for this iteration of the loop, we go into the event object and get the corresponding index number that says where the information for that unique pointer ID is stored in the current mouse event object. So once we have that information, we then go and check if our path map contains a key for the specified pointer ID, the unique value, and if it does, we then go into the body of this if statement and we capture the x and y coordinates for that unique pointer ID, and that unique pointer ID's coordinates are located at the index number that we retrieved back here on line 176. Next, we get the path object because we're going to place a new line segment into that path, and we get the previous point from the previous point map. Then at lines 191 and 192, we calculate the change in x and the change in y. And if the delta values are not big enough, we will simply ignore this event. But if they are big enough, if either one of them is big enough, we will then at line 198 and 199 call the quad2 method, which is going to draw a quadratic curve from the current point to the new point, and that way create a nice smooth line from one point to the next. And then finally at lines 202 and 203, we update the point object's x and y coordinates to the new x and y, so that in the previous point map, when we come back to this again for the next point in a given path, then we will be able to calculate the distance between what is now the new point and the previous point in the path. We then come back around to the top of the loop and do this all over again for each individual unique pointer that is part of the current motion event being processed.